Okay, volumes revolving around other axes. Can you believe this is the last lesson of the year? Just like we did with the disc and washer method, we're going to pretty much do the same thing here. Only in this case, we're going to revolve around some other line other than an x-axis or a y-axis. It'll be a different line, so we'll have to consider some of those things revolved around any other line other than the x or the y-axis. So you ought to feel comfortable with that. We just have to generalize these findings. So I've got some pictures here to kind of help us wrap our brain around this. If we're revolving around a horizontal line, such as y equals 2, y equals -4, 5, whatever, we're going to have the outer radius and the inner radius are going to be functions of x, and we're going to integrate along the x-axis because it's a horizontal line. So it's behaving like it's an x-axis. This is just the general format. So here I have my outer radius back to the x-axis. We're revolving around here. And then my inner radius would be from here to here. So r equals c here. That would be the line. And little r would be c minus f of x. So capital R is just the equation, the horizontal bar we're revolving around. Baby r is c minus the f of x. So it's making a washer. We're keeping all of this. We're throwing away this. The purple or blue is what remains. And we want, actually, let's use the space out here to write our volume formula instead of rewriting that again. Okay, so our volume formula would be from A to B, pi, capital R squared minus pi, baby r squared in terms of x. Need more space. Okay. In this next example, we have the line of the line is going to be below, so y equals c in this case is a negative value. We want to revolve capital R. So if you think about this, it would be like capital R is f of x plus c, because c is going to be negative. So it would be like the function minus some negative number here. So we're adding that c value. And lowercase r, or baby r, is from here, 0, down to the axis of rotation. That's where we're going. And that volume would be from A to B, pi, capital R, squared minus pi, lowercase r squared. We could pull those pi's out and make that look a little prettier. From A to B, f of x plus c squared minus baby c squared. Okay. Then in this case, we have okay, let's see here, our outer radius, we're spinning around, we're spinning around this line, y equals c. So our outer radius is c minus g of x. That's the furthest away. And our inner radius is the other part. Let me rewrite this. That won't work. The outer radius goes from here down to here. Capital R is C minus G of X, and baby r is in here. Baby r is C minus F of X. So the volume is pi from A to B for capital R is C minus G of X, quantity squared, and lowercase r, C minus F of X, quantity squared in terms of X. And then our last one, we've covered every possible combination of horizontal axes. So capital R would be the furthest down to our axis of rotation. Capital R is F of X minus a negative C, so we would add, and lowercase r, or baby r, is G of X minus a negative C. And that volume formula would be pi from A to B of capital R plus C, quantity squared, minus lowercase r, G of X plus C, quantity squared, dx in terms of X. So once you do about 5 or 6 of these, you kind of get the hang of it. Just have to be really careful setting them up. So here we go. We got the square root of X, Y equals 0, and X equals 4. Those are our boundaries. We're going to revolve around the line Y equals 4. So we don't want to go past 4. Let's put 4 right there. Shade that in. So we're taking that little shape. We have an outer radius from here to here. That's the outer, capital R. We have the lower case r from here to here. We're revolving around that line, which is y equals 4. So the outer radius is 4 minus 0, and the inner radius is 4 minus our function value. And this is going to make a washer because we aren't touching, we're not touching that dotted line axis of rotation, y equals 4. So volume is pi from A to B of the outer radius, that's 4 squared, minus 4 minus square root of X squared dx. You expand all of that from 0 to 4. We have 16 minus 8 square roots of X plus X dx. And the 16 minus the 16 is going to cancel out, and we'll end up with a positive 8 square roots of X minus X. And then we're ready to integrate. So the volume is 16/3 X to the 3/2 minus 1/2 X squared from 0 to 4. And that would turn out to be 128/3. Just going to get a common denominator here. I pre-worked this one. So our volume is 104 pi over 3. Cool. And these are a little tedious, easy to make mistakes. All right, so we have y equals 4 minus x squared, y equals 0, and we're going about the line -1. So we're going to go 4 minus x squared to y equals 0. This is the line -1. So shade that in. Oh, my coloring skills lack. Okay. So let's see, this would be at -2, 0, and this would be at +2, 0. Our outer radius goes from here down to the line. That way you can see what's happening. 4 minus x squared minus -1. That's how we come up with the plus. So 4 and 1, that's going to be 5 minus x squared for the outer radius. The inner radius is going to go from 0 minus -1. So 0 minus -1 is going to go to 1. And again, this is a washer because we have this hole in here. This is getting all thrown away. So the volume, I'm going to use symmetry here. And we're going to integrate from 0 over to 2 and double that. You with me on that? So we got 2 regions that are the same size from 0 to 2. Outer radius minus inner radius and then being careful with your expansion. That's 24, 10x squared, x to the 4th. Well, 25 minus 1, I did that ahead of time, looking ahead. So 24. Now we can integrate with 1/5 x to the 5th, 10/3 x cubed, 24x, and we're substituting our values from 0 to 2. 2 to the 5th, that's 32 over 5. 2 cubed, that's 8, times 10 is 80/3. And 24 times 2, that's 48. So we need a common denominator of 15. So this one needs a factor of 3, that's 96. 5 times 80, that's 400. And then 15 times 48 is 720. No, I didn't do that in my head. And that volume or that fraction adds up to 416 over 15 times 2. So our total volume is 832 pi over 15. Okay, let's go to the next axis. So we got about, what, 4 or 5 more to do. So now our axis of rotation is going the other way. We're going to revolve around a vertical line. It's going to be, our slices are going to be perpendicular to that vertical line. This is going to be our outer radius from the y-axis over to our axis of rotation. That's our R of C. And this is the inner radius, little r, is C minus the function. So the volume, when our vertical axis of rotation is to the right of the function, it's going to be pi from A to B. These are y values now. Wait, I didn't write this right. Let's back up here. This is supposed to be pi r equals c. R equals c. So we have pi r squared minus pi baby r squared. And I'm writing in terms of y, and I'm putting in x's. Oh, it's a long day, because x is in terms of y. Okay, on the second one, here the axis of revolution is to the left of the function. So our capital R is going to be from here over to here. Capital R is the f of y minus negative c. And you see I did that up here again. Not paying attention. Okay. And then the baby R is C. And the volume is pi from A to B. The f of y minus negative c squared minus c squared dy. Okay? Now when the axis of revolution is this way and we've got two shapes, we'll have to subtract them. So the farthest away is going to be c minus g of y and c minus f of y for the inner radius, and c minus g of y for the outer radius. This is for the inner radius. Volume is pi from A to B. Outer radius, c minus g of y squared, and the inner radius, c minus f of y squared in terms of y. And the last possible condition would be when the axis of revolution is to the left of the shape. Outer radius goes from f of y over to c. Inner radius goes from g of y over to c. Baby radius, big radius. Outer radius, inner radius. It's the inner radius that gets thrown away. The volume goes from A to B, and the outer radius is f of y minus negative c, minus a negative squared, and the g of y minus a negative c squared in terms of y. So there's the 8 possible combinations of revolving around an axis. So it's top minus bottom, or right minus left, or outer minus inner, whichever way your brain gets it wrapped around there. This one's a calculator question. Find the volume approximation of the solid generated by revolving the region bounded by the cube root of x, the x-axis, the line x equals 1, and we're going to revolve it around the line x equals 2. So the cube root of x looks something like that. And we're going to stop at x equals 1. We're going to revolve it around the line x equals 2. This is our x-axis. This is the axis of rotation. Here's the shape, this little region here. They're stopping us at 1, the x-axis. This is the y-axis. Okay. At 1, 1, I would say 0, 0. So if x equals y cubed, the outer radius is going to be 2 minus y cubed, and the inner radius is going to be 2 minus 1. 2 minus y cubed. Inner radius is 2 minus 1. So the volume is pi from 0 to 1. I'm making the assumption this needed to be worded better. 2 minus y cubed squared minus 1 squared dy. We're going to the calculator. Okay, so menu, calculus, 3. I need a pi here. Pi times, pi times the area from 0 to 1. We have 2 minus y. I'm just going to use x's. 2 minus y cubed quantity squared minus 1 squared dy. 15 pi over 7, and 15 pi over 7 is about 6.732. So the volume on the calculator exactly is 15 pi over 7. If we needed a decimal approximation, 6.732. So either one, when they don't tell us. Okay, let's see what this one is. We've got y equals x squared. That's a parabola. Y equals 4. We're going about the line. Y equals, or x equals 3. So that's a vertical axis of rotation. So y equals x squared. We're stopping at 4. So that means 2, 4, and negative 2, 4. We're going around the line. X equals 3. And we want to do, let's see, the outer radius is going to be 3 minus negative square root of y, because I'm solving this. If y is x squared, then x is the square root of y. So I'm thinking about it this way. I've got the outer radius from 3, right-hand side, all the way over to there, because this piece of the graph is the negative square root of y. And this piece of the graph from 0 is positive square root of y. That's going to be the inner radius. This is the outer radius. This is the inner radius. So our inner radius is 3 minus the square root of y. It's a washer. We're getting rid of all of this white space in here. Volume is pi from a y to a y. What was this y? 4. Okay, from 0 to 4. Outer radius 3 plus radical y squared. inner radius 3 minus radical y squared dy. We'll have some things cancel away here once we expand. 0 to 4, that's 9 plus 6 square roots of y plus y minus 9 minus 6 square roots of y plus y dy. What's going to go away? This 9 minus this 9, this y minus this y. We end up with 12 square roots of y. So we're going to integrate from 0 to 4, 12 square roots of y dy for the volume. That gives us, let's take the 12 out too. Too much work. Okay, do-overs. The volume is 12 pi, and then y to the 1/2 power is 2/3 y to the 3/2 over our interval from 0 to 4. So that's what? 3 goes into 12, 4 times 2 is 8. So we have 8 pi with y to the 3/2 minus 0 to the 3/2. So the square root of 4 is 2. 2 cubed is 8. 8 times 8 pi is 64 pi. Our volume is 64 pi. That wasn't bad. It looked a lot harder than it was. Number 7. My goodness, this lesson has a lot of examples. 2 times the square root of x. That looks like this. And y equals x looks like that. We're revolving around the line x equals -2, so that's over here. We have this area in here, that little tulip shape. Our outer radius is going to go from all the way out here, all the way over to the line. That's our capital R. Our baby r that gets thrown away goes from there to there. And our function is, let's see, we got to solve for y. So what's this one? Y over 2 is y over 2 squared. I'm solving this in my head, so that's 1/4 y squared is 1x, and the other x is just y. So the outer radius is y minus -2, and the inner radius is not y minus -2. Hold on. I was right. That was right. Y minus -2 is our outer radius, so y plus 2. And the inner radius is 1/4 y squared minus 2 minus -2. It's a washer method. The volume will go from 0 to 4, and we'll have y plus 2 squared minus 1/4 y squared plus 2 squared dy. Get rid of that. Expand those out. Pi from 0 to 4. We got y squared plus 4y plus 4 minus 1/4, what's that? 1/16 y squared plus y squared plus 4 dy. And what's going to go away? So the y squareds are gone. The 4's are gone. And we got 4y minus 1/16. That volume is 4y minus 1/16 y to the 4th. Miss that square, dy. So the antiderivative is going to be 2y squared minus, let's see, 16 times 5, that's 80, 1/80, y to the 5th from 0 to 4. Our volume is pi, let's see, 4 times 2, 16, that's 32. And let's do a little magic here without a calculator. I got 5 y's, 5 4's, and 80 is 16 times 5. So without a calculator handy, we can eliminate this and get a common denominator. What'll that be? 5. So we got pi, that's 150, 160, 160, and 4 cubed is 64. 160 minus 64. What is that? 96 pi over 5. Volume, 96 pi over 5. 6 and 4 is 10. 9 and 6 and 1. Gotcha. Okay, almost done. 3 more. X is e to the y. X equals e to the y. So that's going to look like this. Whoop. I have a hard time drawing curvy lines. It's going to start at 1, 0. And it's going to go curvy like that. About the line x equals 1. So we want to stop it here at 1. Stops here at 1. Y equals 1. This is this line, y equals 1. We're going to revolve around that line. And our shape we're coloring in is right in here. That little curvy area. This point would be e to the e and then 1. And this point would be 1 and then 0. So x is e to the y. Y is natural log of x. And we're going from the top. So this is a disk. There's no inner radius, just an outer radius. This is a disk method. It's going to be 1 minus natural log of x. So there's none here. That's an easy one. Volume goes from 1 to e. We're going on x's. And it's pi r squared. This is a calculator question. So clear that out. Menu, calculus, integral from 1 to e. Need a pi out here. Pi times, and then what's our value? 1 minus natural log of x. 1 minus natural log x quantity squared in terms of x. And there's one answer, but we can do Control, Enter, and get a decimal answer. So it's either 2e minus 5 pi or 1.372. So the volume is 2e minus 5 times pi or 1.3715, either one of those. 2 more to go and we are done with calculus for the year. Well, then we're ready to study. So the cube root of x, you know, it looks like that. We're going to start at 0, y equals 0. We're going out here to 8. It's going to be a disk because it's touching the axis of revolution. We're going around that line, shading that region in. And we said it's a disk because it's only got one radius, capital R. So there's none here. And we have 8 minus, let's see, y cubed, because we solved for x in terms of y. And the volume goes from 0 to 2, 8 minus y cubed, quantity squared, dy. And one more calculator question. Menu, calculus, integral, from 0 to 2. And I keep forgetting the pi. I'll put it inside this time. Look, pi times. Now we're done. Get out of there. 8 minus y cubed. 8 minus y cubed. Quantity squared dy. And 576 pi over 7 or 258,508. So this one, exactly 576 pi sevenths or 258,508. You wish you could say this is the last calculus problem you'll ever work, but we know that's not the truth. So 2 square roots of x, I believe, is going to run into 6. When this is 6, it's the square root, so that's 9, 6. We're revolving around the line, y equals 6. This is one more disk method, so there will not be an inner radius. We'll have an outer radius. It's going to be that region there. We're starting at 0, going to 9. So from an x to an x, our radius is 6 minus 2 square roots of x. The volume is pi from 0 to 9. 6 minus 2 square roots of x squared dx. And our calculus integral goes from 0 to 9. We got a pi. And the integrand is 6 minus 2 square roots of x squared with respect to x, 54 pi or 169,646. So exactly 54 pi, or approximately 169, 646. And that is the end of our new information for calculus.